Hello everybody and welcome to a brand new video. Today we are going
How's that? There you go. Okay. Okay, so ano, musta guys? How was the contest? Any comments, feelings? Wait, you guys can hear me, right? My man. Okay, yeah. GG. How do you guys feel naman about the problems? Okay naman? Or how to see? Yeah, it seems a lot of people were stuck at C. So yeah, let's start now so we can make our way to C and D, which are like the more interesting problems. But there's some stuff to say naman about A and B. Okay, so let's start the discussion na. Alright, let's look at problem A. Analyze yung problem A. So we have this equation, A plus B equals C. And it's not always correct kasi sometimes you have your 2 plus 2 equals 5. Or itong 1, 2, 3 plus 4, 5, 6 equals 7, 8, 9. And then the only operation that we have is you can plus 1 to A, or you can plus 1 to B, or you can plus 1 to C. So the question is, what's like the minimum number of moves that you need to do in order to, you know, make the equation correct? The thing about this question is actually yung A plus B, the fact na hiwala yung A and B, actually wala yung silbi. Basically, we just have like yung A plus B, whatever that is, on the left-hand side. And then we have C on the right-hand side. Tapos we want to make them equal. And the only thing we can do is go +1 at a time. So I think you would agree that it's like... Let me open my notes. So it's like we have this value here, whatever A plus B is. And then we have, let's say, C. Let's say for drawing, we want to put it here. And we want to make them equal, but you can only move like one step at a time. It's like 1, 1, 1. And actually, I think just from looking at the drawing like this, it's clear na actually the distance between them is the only thing that matters. Kasi it doesn't matter if A plus B goes all the way to C, or kung si C naman goes all the way down to A plus B, or maybe they'll meet in the middle. Like if they meet in the middle. Actually, that's all the same. So the only thing that matters is the distance between those two quantities, C and A plus B. And to get the distance between them, we just do yung absolute value. Because we want C minus A plus B. But that's only for this picture where C comes after. It's pwede rin na C is the smaller one and A plus B is bigger. In this case, you'd want A plus B minus C. But, you know, for our convenience, there's a function that encapsulates both of these, which is just absolute value of A plus B minus C. And that's going to give us the distance between the two. And probably the hardest thing about this is actually just extracting the A, B, and C. For C++, it shouldn't be too hard because you can accept things one token at a time. So you'll just read an integer, tapos dummy read a string, read the next integer, dummy read the string, read the next integer. For Python, you have to read the whole thing as one line. But okay lang yan because we have spaces, so we can just do split. So we could just say, let's say args equals input dot split. I'll zoom in. And then what we have? A is equal to the first argument. And then C plus nandun, but we can just ignore it. It doesn't matter. B is equal to this one. We skip the plus. We'll also skip the equals because we don't care about that. And then just print out abs. Most languages naman have a built-in abs. A plus B minus C. And I think that should work. 1 plus. Let's just try that. Anyway, yeah. While this is running, while I test it, can you guys type 2 in the chat if you're okay now with this solution for A? So, guys, can we move on? We're good with A. Alright, nice. Sorry, mukhang may konting latency, so I'll just have to get used to that when I'm trying to do interactivity. Okay, so if we're good with A, let's move on with B. B is actually already starting to be a bit interesting. So what is it? Oh, right. We just need to find a cutting point so that left half, like some of the guys in the left half is equal to some of the guys in the right half. So we just need to find if like such a cutting point exists. So, okay, let's see. Let's go problem B. And I think the most straightforward approach that we can think of is to just try all the possible cutting points, diba? So let's, what's the input look like again? So n equals input, and then a equals, let's just read the list of integers. And then what we want to do is get all the let's say for what is the problem? K. That's what they use in the problem. So for k in range 1 to n, and then for non-Python users, I'll just leave a comment here. This means the range 1 to n minus 1. So we want if the sum of the first k elements equals the sum of the elements that come after it, right? This is just saying if sum left half left of k then ans equals k and break, and then we'll print ans. So let's see, 3 1 2 3. Okay, 2, that's correct. And then I'll zoom out a bit. So 4 3 1 4 1. Tapos ano yan? -1. Okay, so this is correct. This is actually a correct solution na. Right? But is it efficient? I mean, mukha naman siyang efficient, right? Because we do have to have this for loop somewhere. Tapos konti lang yung code sa loob niya. So that feels like it should be fast enough. Pero hindi, this is Python hiding some magic. So for instructive purposes and also for the benefit of people who don't use Python, let's try to expand these sum functions so we can see what's happening under the hood, what Python is doing under the hood. So we'll do left half equals 0, and then for I in range k, we'll go left half plus equals a sub I, and then right half equals 0 for I in range from k until n, right half plus equals a sub I. And then we took the sum of the left half, and then we want to check if the sum of the left half equals the sum of the right half. So, yeah, good question. How fast is sum? Well, by necessity, we can't really assume too many fancy things about the array. So, under the hood, Python has to do this. And this is how you do it in, like, you know, a lower level language that doesn't have these fancy sum functions. And now we've exposed the hidden for loop. Yeah, we have for loops nested within another for loop, and that's bad. So we have these two for loops. This one goes from 0 to k minus 1. Tapos this one goes from k to n minus 1. So actually we're moving this pivot point k, but actually, like, let's go to new. Like, let's say it's 0, 1, 2, 3, 4, 5. So we're moving the point k. Let's say k equals 1, 2, 3, 4. But overall, it's still going through the entire array. Right? The left half and the right half have changing sizes, but the total size of the left half and the right half is still going to be the entire yeah, it's gonna be the entire array. 1, 2, 3, 4, 5. So we have k from 1 to n minus 1, and that's approximately n. And then at each iteration, left half, left plus right, still gives us like the whole n. So n steps. So because of that, our nested for loop here, this means this code has a runtime of n times n, which is O of n squared. And remember, the rule of thumb is like 1 billion or something, or 100 million. That's how much we could do in 1 second. And if we take n squared and we plug in n is 200,000. N squared is 4 times 10 to the 10. That's bigger than 10 to the 9. So di pwede. So this solution is correct, but it's not efficient enough. So gets naman with how that's like too slow, right? Okay, so that's too slow. We need to remove some calculations that are a bit, they're a bit redundant. And there are a few ways I can think of doing it. I'll propose one, which is one possible way, which is that let's note that left half plus right half equals sum of all elements. So that means left half equals sum of all elements minus the right half. So what I could do is I could have this total, and then I'll just make that the sum of all A. Basta like, okay, whatever, basta my for loop, but you get naman what I just want to do is take the sum of all A. And then instead of having this other for loop here for right half, I can just go right half equals total minus left half. And we've already cut out one of the for loops. Right? Gets naman how you can get the right half as like total minus the left half. Because if it's not the left half, it has to go in the right half. And what that does to our complexity is that ito na lang yung kailangan nating gawin. This part here. And all of this disappears. Oops. Question though. We got rid of one of the for loops. We got rid of the right half for loop. So, ito na lang yung work for left half. Do you think this is like significantly better pa rin? Like, will this pass? Having just eliminated the right loop, but we still have this for loop for the left half. Well, okay, I guess I'll just say now, because, sorry, the latency is making it a bit hard to do interaction. This is still n squared. Yeah, it's better than before, that's correct. It's better than before, but it's still not, like, super optimal. Yeah, because remember that this big O notation, you can learn the formal definition of big O notation later on, but Like right now, we just treat it to mean approximately n squared. And when we say approximately, we mean we remove smaller terms, we ignore the stuff that's not important, and we also suppress constant factors. So we went from n squared to half of n squared. And I think you can visually see it's half of n squared because we used to have this square before, and ngayon it's just this triangle that's half of the square. So half of n squared is better than n squared, but it's still way too big. That's still like in the family of quadratic functions. And if you do like 1/2 of 2 times 10 to the 5 squared, that's still like too much. So we can't do that. The final thing we have to fix is that, notice na parang redundant yung itong computation dito. Because, well, I'll go back to this diagram here. Why do I have to recompute this entire left half the whole time at each step? Right? Doesn't that seem wasteful that we have to go all the way until the end every single time? When, like, if you look at it, at each step, there's only one new element that gets added anyway. So we can just reuse the computation from before. And then just add in this new element. You add in the new element, and then you should get, like, the next left half. And we only had to add one thing. So, just to make that clearer, instead of recomputing this entire left half the whole time, I'm going to keep, like, a running left half. Like, I won't start from scratch. I'll carry over from previous into the new one. And the only thing I'll do is add the next element. So, let's just remove that. That's true. So that's where we're at right now. So I think you guys can see naman, just like try to play it out in your head. It makes sense na. Oh, and right, we have to start from 0 now because of how we're doing it. But yeah, I think you can see it, right? Na left half equals 0. And then to get the next left half, you just add in the next element. And then to get the right half, we just do this pre-computed total minus the left half. And then you check if they're equal. If they're equal, ans equals k break, print ans. Right? Can you guys type 1 in the chat if you're good with this solution to problem B? Nice. Okay. So, guess we have some ones. I will be linking this this drive naman so you can look at the code. Okay, let's move on to the spicy problems. Let's move on to C. Or I'm sorry, let's move on to K. Keep it safe. Oh. Looks like I was off in my difficulty estimate because less people got K than D. Oh well. Well, I'll improve next time. Sorry. But okay, let's see. Oh, answer equals k plus 1. Okay, right. Yeah, because we're starting from 0 to n minus 1. Correct, yeah. Thank you. Again, sorry about the delayed reactions because of latency. So, okay, ano yung problem K? We want to count the number of access codes na, like, it's a length, let's say it's a string of some length. The length is between L and R. And tapos, like, the alphabet has size S. And we want there to be, like, at least N guys. Well, first, let's just make things a bit simpler. Let's just get some stuff out of the way. If the size is S, then if you remember basic combi, like the number of, like let's say dito si 5. So I have S possible symbols as the first character. Tapos there are S possible symbols for the second character. And then S possible symbols for the third character, and so on. And we just want all possible strings. Walang ibang condition. So they're all independent of each other. So we just have S choices at each blank. So for a fixed length, the number of valid access codes would be S to the length. Or let's make that a bit less bad. S to the length. Yes, correct. So x to the L plus x to the R. So, well, I'll use S because that's the one naman in the problem. So we want to say find the smallest S such that S to the L plus S to the L plus 1 plus dot 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 plus S to the R is greater than or equal to N. Now, if you're coming from it from, like, let's say a very straightforward, let's say you just want to use a textbook approach that you learned in class, like, you know, maybe you recognize quadratic inequalities or something, blah, blah, blah. So you want to solve for the roots of this polynomial, and then yun yung sagot. But, like, in practice, ang hirap nun because maybe kung quadratic pwede pa, but S goes up to, like, what? The R can go up to 6. And walang formula for, like, sixth roots or, like, yung degree 6 polynomials. So, okay, let's scrap the polynomials. Actually, that's not gonna help us. Oh my gosh, I just realized I'm not sharing my notes. There you go. So I'll just leave it there for a bit because I forgot to change screens again. So step 1 lang yung combi because, okay, basta the combi gives us a magic formula, and then the problem is find the smallest S such that yung magic formula na yan is greater than or equal to N. Oh my gosh. You know, the latency wasn't always this bad in our past streams. I don't know what's going on right now. It's like there's a 10-second delay, and then that turns into a 20-second delay because I have to wait for the chat anyway. So, before I move on, like, is the combi magic formula clear? And then, why it's basically just solve this problem? Can you guys type 1 in the chat if, like, okay, we're good and we can move on? I'm good with this formula na. Okay, so I'm going to actually describe two different solutions. I think that there are two solutions to this problem. One is like a mathy approach. Tapos the other is like mas algorithmic, brute forcey approach. I'll start with the algorithmic approach kasi this is a programming contest, so I think it's natural. And I think I'll pull up my interactive Python terminal. So, here's the question, basically. If I asked you to solve this by hand with like without a computer, or maybe you had a calculator, okay. You don't have like a programming language, whatever, but you do have a calculator naman. How would you solve this problem? Well, I have something a bit better than a calculator. I have this interactive Python shell. So I'll just do some convenient stuff. Like I'll define this function f l r s, and then return sum of s to the k for k in range l to r plus 1. Like basta ito yung magic formula natin. Like for instance, if we test the one in the sample. Okay, yeah. So, if you have this magic formula, how would you solve it? Like, quote-unquote, by hand. Hindi naman totoong by hand because we have a calculator to do the tedious computations for us. But like, you know, how would you approach this before you learned any fancy math in school? Yeah, guess, diba? Guess and check. So maybe in grade school, they would tell you guess and check is wrong or guess and check is bad because it's inefficient. But I'm here to tell you that in CS and programming, guess and check is a valid solution. As long as you're guessing smartly, okay lang yan. Because the computer can do a lot of stuff. We can make the computer do a couple of guesses for us. Okay, let's do guess and check with a computer. Yeah, trial and error, trial and error. So, how would this go? Let's say n equals, let's say a billion. That'll be our example here. Guess intelligently, yeah. So, let's see. What do I want? Let's try 5. Let's try 50. If I try 50, and let's check if that's greater than or equal to n. Okay, that's not. So I tried s equals 50. Or, sige, let's try that. S equals 50. I tried 50 and it wasn't big enough. So what should I do? What should my next guess be? What do you think? Yeah, guess higher, right? Because, well, intuitively, itong magic formula natin, it's what we would call formally increasing in S. If S is bigger, then itong F also gets bigger. And that makes sense, right? Kasi it's a counting function. If we have a bigger alphabet, then of course we'll have more access codes. So if 50 was too small, then anything smaller than 50 is also too small. So we have to guess bigger. Okay, I guess 1,000 daw. Okay, so let's say S equals 1,000. If we do that, that is... Oops. Yeah, that's too big. That's already bigger than a billion. So we guessed 50. 50 was too small, so I'm gonna do a bigger guess. I'm going to guess 1,000. 1,000 is too big. This is bigger than a billion. So if 1,000 is too big, what should my next guess be? Yeah, mid of 50 and 1,000. That's correct. So 1,000 was too big. That means we should guess something smaller. Right? 1,000's too big. Okay, our guess should be smaller. But you're right. We shouldn't forget about 50. Like we can keep the information from past guesses. So we know it has to be bigger than 50, and we also know it has to simultaneously be less than 1,000. So if I draw it here, then let's go a new page. We know that the answer has to be like greater than 50, so it's somewhere here, somewhere in this range. And then we found 1,000 was too big, so okay, it has to be somewhere in this range. It has to be greater than 50 and less than 1,000, so it has to be like, somewhere here. And now we need to keep doing guesses strategically. So okay, someone give me a number between 50 and 1,000. Oh, and I realized the terminal is still covering the screen. Yeah. $900. Okay, let's do 900. If we do 900, I can actually make this a bit smaller. Okay, true. So since it's true, that means we can narrow down our interval a bit. So wait, let me draw this better. That we knew it was between 50 and 1,000. And then now we learned that 900 is too big. So we can narrow it down a bit further and make it smaller. And that's the basic idea of the guess and check, right? You have some range. I know it's in this range. Tapos I'm gonna guess something in between it, and then it'll tell us lower or higher, or lower or higher, and then it'll just keep shrinking and shrinking and shrinking the range, and then maybe it'll get small enough that we can just brute force test it. Okay, so for next suggestion now is 475. Where did you get 475? Can I ask? Yeah, so the question is, I'll repeat again. Sorry if latency means I'm over asking, but saan nanggaling yung 475? Why did you pick that? Okay, yeah. 475 is the middle of 50 and 900. Bakit maganda yung middle? It's because I've already drawn it like this. We're gonna take our guess. This is the new guess. And the new guess has to be in the range. And it kind of partitions this thing into two segments, right? We have this segment here on the left. Tapos we have this segment here on the right. If 475 is too big, then we throw away the right segment. If 475 is too small, then we throw away the left segment. But either way, because it's in half, and this is each half, we have our search space, and then in one guess, so let's say this is the size, and then in one guess, the size has halved. Yeah, it's dividing the problem in half, right? And that's good because but we don't know whether 475 is correct or not. So we don't know if left or right will be the one we keep. So, para fair, para worst case is not too bad, we'll make them equal. So that at the very least, no matter what happens, after one step, the size will get halved. Right? And this fact that the size will get halved is actually like a huge deal because, well, let's say the initial search space was size n. Let's say n is the initial search space. So after one guess, I divide this size by 2. After another guess, I divide it by 2 again. After another guess, I can halve its size again. After another guess, I can halve its size again. And so on. And I'll stop when, let's say, 1 or 2 or something small. Let's just say 1 so it's easy to see. I'll stop dividing it in half pag isa na lang yung segment ko. And then, this is for let's say k guesses. So this is n divided by 2 to the k is equal to 1. N is equal to 2 to the k. And k, which is the number of guesses, is equal to log base 2 of n. And if there's anything you should remember about logarithms, it's that the logarithm is the opposite of exponential. Exponential grows super fast. So because of that, its inverse actually grows really slowly. Right? I'll go back to... Yeah, you can only divide 10 to the 9 about 30 times. Right? Because 2 to the 30 is like a billion. So isn't that amazing? To cover the entire search space of a billion, we only needed to divide in half 30 times. So, okay lang yung guess and check because we only needed 30 guesses for 1 to a billion. That's actually pretty efficient. So, okay, let's actually start coding it na. So, I'll define f l r s, and then this is return some s to the k for k in range. Basta ito yung magic function natin. And then let's say we want to solve. Let's say like the left endpoint is equal to 0. And we do need a right endpoint. Let's say that right endpoint is, I don't know, something like, let's just always make it 10 to the 18. We'll make this a bit smarter later on. Pero surely naman, 10 to the 18 is, like, let's say this is guaranteed to be too small, and then guaranteed to be too big. And then let's go define test. LR and then S. And then what we want this to do is find the smallest s such that test of So what do we want again? While, let's just say, I'll save this for later. While interval is still big, let's say our new guess is the midpoint of left and right. So midpoint of left and right. If, let's say, what do you want? Test LR guess, and then we will set right. Oh no, left. Left ba? We want the smallest s such that this is true. So if this is true, no point in getting bigger, so it should be right. Take new search space is if guess works, no need to make it bigger. Oh, and I guess I should have clarified this earlier. Our search space is left. We know the answer is in here somewhere. Okay, I guess just digest this muna. And can you guys type 1 in the chat if you're good with like this logic of this guess and check logic that we've been doing. Or, I'll call this guess and check. Right. Sorry, I must have pulled this code out of nowhere. But yeah, what we're basically just doing is the guess and check. The guess and check procedure that we did before na higher, lower, higher, higher, lower, lower, higher, lower, higher. And then we're consistent. We're like squeezing and squeezing. We know that it's supposed to be within this interval, and that interval gets smaller and smaller. We keep making guesses, and that guess will let us narrow down where the answer is going to be. If you guys are still digesting, or maybe there's something you find confusing, you can type in the chat naman what you need help with. Let's put more comments. Maybe that one. And how is everyone else? Are you okay? Did I jump a few steps? Can you guys like try to verbalize which part of this is like not clear? Okay, you had the same idea, but I don't know when to stop. Okay, we could fill in this detail. So what we could do is, while this interval is too big, let's make it stop somewhere nice. Let's say, well, right minus left is greater than or equal to, I don't know, let's pick some small number. Let's say 4. So when we stop, parang maliit na lang yung interval. Like, we've narrowed it down to 4 or 5 numbers or something. And if we've narrowed it down to 4 or 5 numbers, then we'll just test it normally for ans in range. if it might help to think of it this way na ano, we can just brute force guess one by one from left to right. If I remove this thing, if I remove that entire thing, tama pa rin yung solution ko. It's just that the search space was still too big. So this is going to take too long. Because I could just check everyone one by one, but then this is going to take too much time. So what I could do is I can just put this back in. I'm going to keep narrowing it down with guess and check. It lets me narrow down like the location of the answer. And then once this is small enough, it's like, well, okay. Like left to right is just 4, so I can just do the brute force after this when I'm done. There are proper ways to do this technique na you do some like maybe left or right exclusive something. May careful if statements ka something. But like in my opinion at least, when I think of this technique, I just always kind of brute force when the interval is small enough. Because to me, that's easier to think of than thinking of all the edge cases pa. Like, I don't want to think. I just want to make my computer do the work for me. People who are not Lyriloy, are you still alive? Yes, okay naman. Like, sort of gets naman. Lyriloy's alt, of course. So, yun. Anyway. Can you guys like type 1 in the chat if you're already good with this solution? Or okay, kahit not good, ano. Type 1 in the chat if you sort of get the main ideas naman. You sort of understand how to do guess and check. If you're okay with that, type 1 in the chat. And then I'll send this code. And then you can maybe digest it and study and read again. Like, basta you understand that the essence is guess and check, then you can just study on your own time na this is how I implemented guess and check in code. When I say type 1 in the chat, yeah, type 1 in the chat. Hello, Naomi Mendoza. One. How about the others? Dalawang 1 lang ba? Okay, sige. The reason why I put this in K is because there's this, and I think guess and check is an intuitive idea. Maybe you haven't implemented it this way before. This technique is called binary search, by the way. Binary kasi midpoint, splitting it into 2 segments, and then that's how our searching works, keep splitting into. So, that's one possible approach. There's actually another way, which is a bit more magical, but it's easier to code. And it goes like this. Let's make a new... If we wanted to do, let's say, x to the 6th plus x to the 5th plus x to the 4th plus x cubed, and greater than or equal to some n. Wait, sorry. Latency, I'm reading. Shouldn't the final for loop be checking if the count returns exactly n? The problem said at least n, actually. The ano. Here's the test function again. It's checking if it's greater than or equal to n. And the problem's asking for at least n. So greater than or equal to is what we want nga. Okay, so is there anything else before we move on to ano? To like this alternate solution, which I promise is pretty fast. Nice, one na. Good to hear. Okay. So we want to compute, let's say L equals 3, R equals 6. We want to solve this. Well, we'll do this technique called solve an easier version of the problem, or easier version / wishful thinking. Paano kung ganito lang siya? X to the 6 greater than or equal to n. Ang dali lang nun, diba? Kasi if it's just x to the 6th greater than or equal to n, then actually we can just do exact solution na x is greater than or equal to the 6th root of n. So in this case, we would say x equals n, 6th root of n rounded up. Alright, so ito yung complicated version. May mga pa-epal pa na ibang terms. But if we're like, okay, easier version muna, paano kung x to the 6 lang yan? Well, in this form, we can just do nga this solve for x, which is 6th root of n. And so if it has to be at least that, then just round it up. So, can you guys type 2 in the chat if this is clear so far? Now, we took the easier version, and it's just do rth root and then round it up. Two. Okay, good. Okay, so some people are following along naman. So, if in the easier version, we'll just do 6th root of n, or rth root of n rounded up. And we don't have the easier version. We have this thing na may ibang terms na pagulo. But like, honestly, think about it. Ang laki ng x to the 6th. And, like, diba when we do big O notation, we say that like the biggest term like dominates the others. Because if you compare, like most of this value, most of the contribution comes from this x to the sixth. All of these other terms, ang konti lang ng ambag nila. Like, let me turn on my terminal again. Right, let's say we have x equals 1000. Then what? Let's say define p of x. And then we'll return x to the 6th plus x to the 5 plus x to the 4 plus x to the 3. And then we'll define p EC. Return x to the 6th lang. P of 1000 is this huge number. P easy of 1000. Like, in terms of order of magnitude, halos same value lang yan. What's P of 200? Oh, P of EC, 200. Ayun, halos same value. May konting 3216, but you know, it's like, for the most part, it's 6.4 times 10 to the same magnitude siya. So, actually, most of this stuff is like mostly irrelevant. Oops, let me... So actually, here's what we can do that I propose. Just like... Ano to? Define solve L R N. I'll copy paste this F from earlier. And then I'll just say estimate equals like rounded value of n to the 1 over r. This is like, you know, the answer is probably around here somewhere. Let's just look around the estimate, you know. We could do some math. Actually, you could do some math to like bound this properly. You can do some math to precisely show how close it is to this estimate. But I don't want to do math right now. I just want to do computer stuff. So I'll just check a whole bunch of values around this estimate. So I know, let's go for error in range -10 to 10. This one, let's see. Guess is equal to estimate plus error. And then if f of L R guess is greater than or equal to n, return guess. And that's it. That's the whole solution. Pero intuitively gets naman, diba? It's like, because of the easier version of the problem, we know that the answer is going to be around rth root of n. It's gotta be there somewhere. Kasi konti lang naman yung ambag ng hindi x to the r term. Oh, wrong screen pa. My dramatic reveal has been ruined. Okay, eto. This is the whole code. We know that x to the r is the most important term. Like, even if hanggang L equals 1, even if you added all the other things, you know, as an exercise, do some geometric series formula thing, whatever. It's going to be less than x to the r. X to the r really is like the main dominating factor. So, the answer really is like nth root of r. Sorry, rth root of n or something like that. Yan yung estimate ko. And if I were smarter, I would do some math and then I could like prove exactly my magic formula na ito yung sagot. But I don't want to do math, I want to do computer. So, I'll just check in a range around that estimate kasi it has to be around here somewhere. Tapos, intuitively naman, ang lalaki ng exponent. So, probably don't have to check too far. So, here's my guess. It's the estimate plus, somewhere around it. Tapos, if it's okay, if there are at least n access codes, then return guess as the answer. So, you guys good with this? Does this make sense? Can you type 2 in the chat if it makes sense? Or let me make this. Yep, this is the O of 1 solution. Itong binary search is the O of log n solution. Pero actually, my O of 1 solution siya, which is, like, just do this. Actually, there's a few things you have to do pa to fix this. One is that, if the estimate is small, pwede maging negative to. So, I'll have to add the check here to make sure guess is at least 1. Kasi, like, for instance, -4, I don't want -4, I want positive numbers, so at least ito. And also, if r equals 1, return n. Why do I have to do this? It's because of floating point numbers. Ito yung trade-off. O of 1 siya. Like, okay, ito. O of log n yung binary search. Pero yung nice thing about it was that our solution is purely in integers. Dito, sa O of 1 magic formula solution, we start to bring in floating point numbers. And floating point is like kind of messy, kind of gross. So, I won't go into too much detail, but I'm sure you've heard the term floating point error before. Floating point error comes from the fact na basically internally, parang scientific notation yung floating point numbers. So, floating point numbers are internally represented, parang scientific notation. And if you remember scientific notation, meron siyang sig figs. But floating point numbers can only hold like 10 to 11 sig figs. If you try to put more than that, it'll get rounded off, it'll get chopped off. And remember that n can go up to 10 to the 18. So, square root of n is around like 10 to the 9. Okay lang yan, 10 to the 9, that's fine. All of the sig figs will fit kasi hanggang 9 or 10 digits lang naman. But if r equals 1, then the answer is just n itself. And if you convert n into a float, like itong n to the 1 over 1, this will convert it into a float first, and then it'll convert it back into int. But when you converted it to a float muna, naging floating point number, some of the sig figs got chopped off, and they remain chopped off when you converted it back to an int. So as a special case, to avoid floating point hell, we have to just do this. And this should already be the complete solution. Alright, can you guys type 1 in the chat if you're good with this O of 1 solution? Yeah, if you look at a lot of the accepted solutions, I think the accepted solutions for this were mostly binary search because it's a standard technique. So the experienced contestants probably defaulted to that, the guess and check. But I put it at K because I thought more people would do this rth root solution. Pero napansin ko rin na the people who did the rth root solution, napaso sila sa floating point. So that's what killed them. They didn't have this special case. So, okay. I admit, maybe this should have been the D problem. Alright, let's move on to the D problem so we can end this stream. What is the D problem? Dimensions ahead of you. Oh, yun. It's just count the number of triples that satisfy this formula na v sub I plus v sub j times v sub k is equal to y. So, count all of the triples that can do that. So, okay, I'm just going to implement the pinaka-naive solution muna, which is, say, n equals input. While I type in this routine solution, why don't you guys comment in the chat how you're feeling right now? NY dapat. Oh, wait, right. I also forgot. So this is the straightforward solution, and if we look at the value of n, hanggang 2,000 siya. And what we have here is 3 nested for loops, and each of these indices goes from 0 to n minus 1. So that's n times n times n. So this guy inside gets run n cubed times. So O of n cubed yung solution na to. And because n is 2,000, this is too slow. But actually, remember the thing about like problem solving in like programming in comprog, well, like efficiency algorithms in general. We don't need like magical fastest solutions. We just need to be fast enough to get under the time limit. And the time limit, well, sorry, the constraints here say 2,000. So actually, n cubed is too small. Pero pwede pa rin yung n squared. If we can do n squared, if we can get rid of one of these for loops, then we should already be able to pass. Maybe we could get rid of both of them, but that sounds really hard. And, you know, just removing one of them is going to be easier. So, ito yung plan natin moving forward. O of n cubed is too slow, but O of n squared passes. So, our goal, remove one of these for loops. So can you guys type 2 in the chat if this makes sense? Like, this is how I think usually. I always start with, like, the naive solution. It's always worth considering. And then you ask yourself why it's too slow. Okay, this is too slow, so you need to remove one of these for loops. And then now I think, okay, how do I kill one of these? How can I do something smart to kill one for loop? What can I afford to do? Okay, so often keep this too slow. Often squared passes. We need to remove one of these for loops, right? And that's the key. We can keep some of these for loops. So remove one of these for loops. Maybe we could think of that as we can keep 2 of these for loops, but we have to ditch the other one somehow. So let's say we keep J and K. This is a common technique in computer science where I can fix 2 values. I'll fix the value of J and K. And then I'll just iterate over all possible values of J and K. So, alright, let me write that down in words. So, uber smart solution. Find the criteria for all I, J, K. Maybe a bit unrealistic. So how about this? We'll fix the values of J and K. Then try to find the criteria for I in this case. Then just go over all possible values of J and K. Right? Like, ito yung uber smart solution. You know, just no holds barred. What's the criteria for I, J, and K? Maybe that's unrealistic. So what you can do is, if we fix certain values, so si J and K, that's a fixed value na siya, I lang is the thing that can vary. Then can we find some nice rules to find I? But that's only for one particular value of J and K. So what we do, okay, just for loop, go over all the possible values of J and K, just sum everything together. So, okay, let's remove this for I. So let's say for J in range here. So, ganon. We want this to be true. So we want this to be true. So the solution for I is v of I equals y minus v of j times v of k. So solution, let me rephrase this. Isolating I, it must satisfy solution. Count the number of y minus vj. Alright, I'll pause here to help you guys digest. But, yeah. Can you guys type 1 in the chat if so far this is motivated and clear? Okay, so my ones naman. So finally, we've built up to this point. Now we just need a data structure that can do this quickly. And you might be familiar from past ABaKoDa rounds or maybe from other experience. So how about we make a dictionary or map in C++ or hash table, whatever you want to use. So we can just go, let's say, frec for frequency equals just some dictionary, and then for value in v, if v not in frec, and then frec I wanted val. Right. I'm just gonna gloss over this part because I'm sure Vernon's talked about dictionaries before. Basta the only important thing, and this is how we code, right? We just kind of black box things. I could explain what this code means or how it works, but yeah, you guys don't really care about that, right? All we care about right now is, basta if I do this, if I use the map or the dictionary this way, then frec val will be the number of times val appears in v. And then I can just use that here. Actually, there's one more thing we have to do, which is we have to remove double counting. Because right now we ensure that j is not equal to k. But we need to ensure that v of I, we need to ensure that I not equal to j and I not equal to k. So we'll go if y minus v of j times v of k equals v of j, then j would have been included in the frec. And if y minus v of j times v of k equals v of and yeah, this is the full solution basically. Oops. You guys have any questions? Can you guys type 2 in the chat if this is good now with you? Very nice, diba? I feel like it's nice and motivated to build it up from that. We start with the naive solution, then we figure out how to kill one of the loops. And then we'll just use a standard data structure. Like once we've identified the thing that we want to do, then and only then do we think, okay, which data structure can do that quickly? Okay, basta frec can do that quickly. And yeah, basta some details, remove double counting, blah blah, that's not really part of the main idea. But yeah. We good? Let me see a few more twos before we call the stream here. Oh, any more twos? There are 4 people watching. How about the other 2 people? Well, okay. 2. Okay, yeah, our third 2. Okay, so if there are no more questions, I guess we'll just call the stream here, and I'll send this in the Discord and update the GitHub, whatever. Before we go, can you guys like just comment? Was this stream helpful? Did you find it like useful, sir? Okay, what's up? Does the O of 1 solution for K work in C++? Hold on. Yeah, the bot found it. Does the O of 1 solution for K work in C++? Yes, it should. It's just you got to be mindful of precision error, of floating point error. But it should also work in C++ naman. Medyo spooky lang yung floating point error, so, you know. Okay, so I guess we're good. See you guys. I hope you found this helpful. Okay, wait. My sorry, latency. The more accurate solution is the binary search one, right? Well, I wouldn't so much as say more accurate. It's just both of them are correct. Both of them are 100% correct. It's just that for for the one where you actually take the rth root, you have to just be more careful with floating point. Like, it's not inaccurate. You just have to know what you're doing when you're handling floating point. Which, I mean, for instance, if you didn't know how to handle floating point error, you wouldn't have done the r equals 1 as a special exception. So, in general lang din, it's just you have to be careful when using floating point. It's not wrong. It's just that things could go wrong in non-obvious ways, which is frustrating, which is why people like to stay in integers. But there's nothing wrong naman with the floating point solution, if you're careful. Anyway, if we have more questions, just ask it in the Discord na lang. I'll end the stream here. See you guys.